Good afternoon. My name is Ben Weisenberger. I'm an application engineer with Allied PLM Solutions. I want to welcome you to the Allied PLM LunchByte series. Today we'll be taking a look at what's new in Solid Edge ST7. There's a lot of new features in ST7, so we are breaking it up into two parts. Part 2 of what's new in Solid Edge ST7 will be held on September 4th, so make sure you get registered for that LunchByte. For today's agenda, we're taking a look at what's new in the user interface, as well as the part environment. For the user interface, we're going to look at the new template options. For new users or someone who likes more information on commands that you're using, we're going to take a look at some enhanced tooltips. We'll also take a look at some changes to the units, and also an option to reverse how our scroll wheel zooms. In the part environment, we'll take a look at improvements to the material table. Also look at the new quick shape commands, as well as some improvements with user feedback with sketches. We're going to be creating a 3D part, and then we'll look at how we can create a sheet metal part from it. While we do this, we'll use some enhancements with the 3D measurement tool to help create our part. And also the hole command has been improved, so we'll take a look at that as well. And also the new blank body command and how to recognize patterns of patterns. Finally, we'll take a look at the new 3D sketching options, the new quick view cube, as well as keyshot and chamfer recognition. So let's go ahead and get started. The first thing I want to take a look at is the new refreshed Solid Edge startup screen. The new layout is more intuitive with easy access to common tasks. Down at the bottom you can see we have our community page here and our support page and any news you might need. Over on the right hand side you can see it's easier to access any of the tutorials, anything with the user interface you don't understand, or if you want to search and help, we have links to all of those. You'll notice in the recent documents list we now contain a thumbnail preview for each file. This gives us a clear picture of what parts or assemblies we're about to open. Also, if you hover over one of the parts or assemblies, it'll give you a nice preview of it as well. The list of templates and template standards can quickly and easily be modified as well. If we click on the Edit List option, you can see our new template list creation menu here. It's now much easier to change our standard templates. If you installed Solid Edge with the wrong standards, for example, such as ISO, when your company might use ANSI, in this case, if I was on an ISO standard, all I have to do now is just pick the template that I want, and it'll update on my search screen. So maybe I want to change to an ISO here. You'll notice I changed from ANSI to ISO. So it's a lot easier to switch between the different standard templates here. We also have the ability to create a list of our own custom templates. I already have a couple created here. If I want to, though, I have the option to come in and rename them. I can delete them if I want to, or I can always create a new list. So when creating a new list, I can base it off one of the standards I'm already going to use. So maybe I want to do an ANSI metric here. I can then come in and remove some if I want to. I can always add some back as well. At the top here, you see I have user templates listed. In my Solid Edge options, I went to my file locations and edited my user templates. That's located out on my machine. So I browsed out to these different locations and installed my user templates. This could be out on a network, for example, or something like that at your company. So you have the options of using user templates, which you've set up, your custom templates, which you can create right here, or the standard templates that come along with Solid Edge. So for now, I'm just going to stick with an ANSI metric template. So let's go ahead and open up an assembly and get started here. So what we're going to be taking a look at on our assembly is our enhanced tooltips, which are included in ST7. I told you these are good for someone who's just kind of getting started with the software, or if you're unaware of how to kind of use a command, you can always come up and use these tooltips. So if I come up and hold my cursor over the assemble command, we get a nice video of how to use this command. You also get some great information there as well of how to use it. Some of our other commands, we have enhanced information. So on the sketch, for instance, we just have a picture, but we have a lot of good information on there on how to use that command. These can always be turned on and off in our Solid Edge options on the Helpers tab. We can turn these options on and off. Another great enhancement with ST7 is how units are controlled. If we go up to our application button in properties, we see we have a new option here called file units. So I have the option to change the units for the entire part from this menu. Up here at the top, I can change all of our units at one time. So now I'm in an inch pound second unit system here. Down here in the middle, we also have the option to have our dimension style match the length units or not. So if this is active, it's going to change the current style of ISO to match what I've selected up here above, which would be ANSI. I can always turn that off and leave my dimensions as ISO dimensions, or turn it back on. I can also come in and edit these individually. Maybe I want to change one of these to centimeters for my length. You'll notice it also updates some other values here. I'll highlight them blue for us to let us know that we've changed from the default settings. And I can always change it back if I want to, and you'll notice it resets everything down here as well. So just some great new options with that. Finally, one other quick enhancement that I love is the ability to reverse how our scroll wheel works. To change that, I just go to Solid Edge Options in the View tab, and here I can reverse those zoom directions. So it's pretty nice. A lot of people ask for that, so that's a good enhancement there. So let's go ahead and get started with some part modeling. In this demonstration, we're going to create a skid mounting plate for our helicopter. So we're going to go ahead and do a create part in place. We're going to ground the part, and we're going to locate this using a midpoint. For right now, I'm just going to pick a material. We'll talk more about the new material table in just a minute. So I'm just going to pick steel. So we're going to locate this on the edge here at the midpoint. We'll go ahead and just save this part real quick. You'll notice over in Pathfinder, we have the material now added in our Pathfinder. It's a lot easier to see what we have applied to the model itself. I can always right-click on this and get a list of any of my recent materials. I also have a list of favorite materials that I can edit, and if I have more of them here, I can see them as well. If I click on Material Table, that'll bring up our new material table. You can see on the left we have the different libraries. I just have a basic materials library, also a DIN standard materials library loaded, as well as a different standard down here. If we want to, we can add more directories. I could always come up here and add a new directory, or I can create a new material. Maybe I want to create steel 1, just my own new material. If I wanted to, I could copy the values from the standard steel. I can just come in here, copy them, and paste them into my new steel. I can then apply whatever face style I want to. I could come in and apply my own steel and then modify it. Maybe I want to make it a darker color, something like that. So I can come in and edit the different face styles. I can also add this to my favorites list if I wanted to. I can right click and say add to favorites. It'll show up now over here on the bottom of my favorites list. If I want to, I can move this up to the top. So that's easy to select. So right now the material currently applied to my model would be this steel. And that's what I want, so I'm just going to leave it how it is. You can always say apply to model if you want to, but I've already got steel applied to it, so I'm just going to leave it how it is. In ST7, primitive solids can be quickly created in a single step. Here we're going to use the box command, which simplifies basic shape creation. Using key points from the surrounding components ensures that the part that we're creating fits within our design envelope. Synchronous technology makes modifying the shape of the block quick and easy using the steering wheel. I can rotate this face down, give us an angle there. We can add a coplanar relationship to the side face of our block. This ensures that it aligns with the frame gusset that it's ultimately going to be welded to. We need to remove a section of the block to better fit it within our design. So once again, we'll use some background geometry to create a cutout here on the top. And there's our cutout. And turn off the background components for now. Next, we're going to use another ST7 primitive shape. This time we're going to use a cylinder to cut through our block. So again, this saves us modeling time, as we already know. Once the shape is created, we're going to want to go right into the extrude command. So that saves us time in the creation of that. So in many cases, such as this one, it may be quicker and easier to create a shape of a complex component as a solid edge part initially, and then convert that into a sheet metal part later. Determining where the bends should be placed and at what angles can be hard sometimes. So by creating it as a block first, we can reduce the complexity of building this part directly as sheet metal. You'll notice as we sketch, the great graphical feedback we now get. So I can come here and grab those endpoints a lot easier. It also shows up the midpoint. Also notice when we sketch a line here, we get some good feedback showing us the length and angle of our line. Let me get the endpoint there. So you notice we get an angle measurement and the length right on our line itself. So it just makes it a lot easier to see what you're sketching. We're going to do a couple little cutouts here, and by adding these small cutaway areas on the top of our block here, we can control the length of the tabs that are going to be created in these areas when we convert it to a sheet metal part here in just a second. So I finished designing my part. What I'm going to do now is use the part to sheet metal command to convert. So next we're going to use the part to sheet metal command to convert our part into a sheet metal component. To do that, I'm going to transition to order here. Under tools, I'm going to use part to sheet metal. With this, we have complete control over the default bend radius we want, as well as the corner treatment, relief, and gap distances. I'm just going to stick with the defaults here. So all that is left to do is to select which edges of the part represent the bends. So I'm just going to start down here. The material thickness can be changed, as well as our directions. So maybe I want to make this 2 millimeters. I can then continue to pick edges here and bend them up. So in this case, the block that we created represents the outside shape of the sheet metal part. If we want to, we can easily change a corner treatment as well. So I can zoom into one of my corners here and click on this red dot. That'll bring up a table here where I can edit what I want to do to the end condition. We have 7 different options. I'm going to stick with the circular cutout. Change my diameter to make it a little smaller. And then right click to finish my sheet metal part. So there we created a sheet metal part from our 3D solid. If we turn on our background components, we can see that the skid plate needs to be mounted to the helicopter using some existing bolts down here. So to do this, we're going to go into our Inspect tab and use the new 3D Measure functionality to find the exact distance between our existing bolts to drive our whole creation. So to do this, I'm just going to select some of our bolts. You'll see we'll start to get a diameter and circumference. I can select a second bolt down here then. We get an X and a Y value. We can display more detailed information in the dialog box here. And now this now optionally remains on our screen, so we don't have to write this down or remember it when we close down the command. If we go on the options here, you can see we also have the ability to take a cumulative measurement. So if we want to, we can add up, for instance, the surface area of a part, select different faces, and add those surface areas up and it'll give us an overall surface area value for that then. We can also measure some other things, length, volume, surface area, etc. If we want to, we can create variables from these measurements as well. So for now, I'm just going to close out of this. You'll notice my dialog stays open though, so I don't have to remember those measurements. Next, we're going to take a look at hole command and some good enhancements with this. So in the new hole command options dialog, we can simply select a standard. So in this case, I'm going to do an ANSI metric. I'm also going to choose the general screw clearance. Then select a bolt size and a fit. We can see in this case, my bolt size is going to be an M6 because my diameter is 6 millimeters over here in my dialog. So I'm going to pick an M6 bolt. I have the option then to choose my fit, close, normal, or loose. If I do a normal, you see I get 6.6 millimeters down here. Loose is going to make it a little better at 7 millimeters. So I'm just going to go with a normal fit, and I'm going to hit OK on that. And we're just going to use the existing bolt then to drive our hole location. Patterning this hole to the other 3 locations is easy. What I'm going to do is just select my hole first and choose the pattern command. I'm going to start it at the center of my hole. Again, we can see the X and Y distances in the measurement dialog that we need to input to the fixed pattern values to match up with the bolt location. So I can put in our 50 and 30 and close our sketch. And I can finish our pattern and close out of our dialog because we don't need it anymore. So you can see our hole pattern now. To prove that this is a manufacturable part, we can create the flat pattern. So if I go up to Tools, Flatten, I can then create a flat pattern of this part. So I'm going to close and return and come back up to our assembly level. And you'll see our part fits nicely in our assembly there. The next thing I want to take a look at is the blank body command. So to do this, we're going to take a look at the air cleaner shroud, which is here. I'm going to edit into it. We need to prepare this component for manufacturing out of a sheet metal blank. So the blank body functionality in ST7 can create a final blank out of a complex component, and it doesn't have to just be a sheet metal part containing complex bends and deformations. So this capability also works for preparing components imported from other CAD systems, such as the one I'm working with here, which is just a part copy, for forming, stamping, and deep drawn processes. So I'm just going to pick how accurate I want this solve to be. I can add a thickness here and a material and go ahead and let it solve. Any situation where material has to be cut out of a flat sheet can benefit from this command. In this example, you can see the complex punch deformation feature in the middle of the bend and how Solid Edge was able to calculate the flat pattern of this part. So you see when it finishes it, it gives me a surface area before and after. And if I finish the command here, now you can see our flat pattern and our sheet size. So it's a pretty cool command. It works on pretty much anything. So if you're unable to flatten something in ST6, you now have the ability to do it here in 7. Another type of part that would have taken multiple steps to create in ST6 is a spherical part. So we're going to take a look at it, how we can do it here in 7. Real quick, I'm going to inspect this just to get a dimension of this sphere. 16 millimeters. I can turn off my dialog box and close out of this because I can just remember that measurement. And I'm going to edit into this part here. So in ST7, this type of part can be created in just a couple of clicks using the new spherical primitive shape. So the spherical primitive can be used to create a spherical part or to generate a spherical cut, as we were going to use in this case. So I'm going to do a cutout of 8 millimeters. Our clearance value can be modified using our live section here. So we need to add a little bit of clearance, so I can just come in and select our value here and add some room to it so that it fits nicely around our ball joint. So I'm going to go ahead and close and return. And that's our spherical cutout then. Another interesting use of creating a blank body is determining the flat pattern of an upholstered seat. So if I come in here and select this seat, in this part we already generated the blank for the top face of the seat cushion, and that allows us to get the material size that we would need to upholster that seat cushion. So just kind of an interesting use of it, but that's how much material we would need to upholster that seat. So finally, we need to improve the ventilation of the seat. So I'm going to go ahead and hide this. Underneath, we have the seat pan here. We need to increase the ventilation of it. So we can do this by increasing the number of holes in the seat's supporting plate, which we can see over here in Pathfinder that it's been imported from another CAD system. So since it's been imported and has no features, we can use our hole recognition tool within Solid Edge to provide those intelligent holes that we need. Next, we can use the hole pattern recognition command. This will not only recognize a simple pattern of holes, but will now recognize any repeated patterns of holes as another individual pattern. So you can see here we have the option to turn this on and off. Within the pattern recognition dialog, we can choose not to recognize the patterns of the outer holes. We can also toggle between circular and rectangular patterns when a 2x2 pattern is recognized. So the new ST7 pattern of pattern options allow us to change our existing 2x2 pattern and make it a 3x3 layout then. We can also increase the number of holes per group to significantly increase the airflow of our seat cushion. So there's our pattern completed then, and we can close and return and go back to our top level. So new in ST7, just like our recognize hole commands, we've added a new recognize chamfer command. So I've created a quick example to show how this works. Before I do that, I want to show you the open dialog box here. It's a new layout. It's more like Windows File Explorer. It's a lot easier to navigate onto file locations on your machine this way. Same options as before, just a different look to it. And if you want to, you can always change it back to the old look. What we're going to do is browse out here to a folder. I've created a parasolid part, so it doesn't have any intelligence on it. You can see what we would have, some chamfers here on the end, on the inside. So we can run the new recognize chamfer commands. It's under the round options here. I can recognize our chamfers, and just like with holes, it'll make these smart chamfers then. So when I hit OK, they're added to my Pathfinder. I can pick them. The edit definition handle comes up. I'm able to select it then and make a change. So that's a great new feature, recognize chamfers. So the next thing I want to take a look at is designing a wire lift guide for the basket and bowl subassembly of a deep fryer. And here's that deep fryer here. So this part is going to be made from a single piece of bent heavy wire. We're going to be building this part in the context of the basket and handle assembly, which will ensure that the part is the correct size and position and that it fits properly into our design. So we're going to create a part in place. As part of the process of creating a new part, we can specify that this part will be manufactured out of stainless steel, as this is a requirement for the food industry. We're going to save the part then. So to design this heavy wire part, we're going to be using the new 3D sketch commands in Solid Edge ST7. This 3D sketch functionality enables faster design of components that are bent in multiple planes. So we can use the key point of the surrounding component to start our 3D sketch. So I can come in here and grab the center point. As we drag our first line out, you'll notice I get feedback when I'm parallel to one of the three primary axes. So I'm just going to come out here and click and place my first line. You'll notice down here in the bottom right-hand corner is our new view orientation cube. Using this, I can quickly switch our design into a front view before sketching our next line in the same plane. So I'm going to come straight down here somewhere like this. You'll notice as we draw new lines, there's a control for length that we can use to specify a value. But for now, we're just going to kind of click and place our lines, and we'll worry about dimensions later. We can move the 3D sketch triad down closer to where we're going to work. So I'm going to bring it down here and zoom in. When we're dragging an element that is parallel to a particular axis, you'll notice it highlights orange on our triad. We can also explicitly lock to a particular axis by pressing the Z key on the keyboard. So if I press it once, I'm locked to the Z axis. If I press it again, I'm on the X axis now. One more time, I'll be on the Y, and this is the direction I want to go. So I'm going to click to place my line. So again, I want to lock to another axis. This time I want to lock to X and come out here and place my line. Just like in 2D sketching, we can switch from a line to a tangent arc by pressing the A key. And we may want to lock this to a specific plane. To do that, we can toggle the X key. You'll notice on our triad, up at the top right, we're locking the different planes. Also next to our cursor, we get some nice feedback about what plane we're locked to. So I'm going to go ahead and just click to place somewhere around here. I'll come back in and add a dimension in a minute. Next, we're going to use our 3D sketch relationships to define our sketch. First, we can specify that we want this line to be parallel to this face of our part. You can see it updates there. We also want to do a connect. Since we're going to be mirroring this part, I want to connect the center point of our arc to the plane that we're going to mirror across. I can then come in and change the dimensions of my arc. Maybe I want it to be 6 millimeters by 90 degrees. Rounds can easily be added to the corners of the sketch using the 3D fillet command. So fillets can be added by either selecting individual lines or just by simply selecting a corner. I can dynamically drag it, or I can key in a value. And we'll add one more up here to the top. We'll make this one 8. Once again, the view cube in the lower right of our graphics window makes it easy to rotate our model to specific views and orientations to quickly inspect our 3D sketch we just created. We can always rotate that view and look at it from the side to make sure our sketch is right. If we right-click on our view cube, we have settings down here. From here, we can turn off the quick view cube. We can change the size if we'd like to, make it bigger or smaller. If we want it in a different position on our screen, we can also change that as well. And change the color that it highlights as well. A great tip is to reduce the opacity here. So if we take this down to 0 and hit OK, you'll notice it looks like it's gone, but when I bring my cursor over it, it appears. So that's just kind of a cool thing to do. So you can always come back in and change the options as well. So that's the new view cube. So we're going to be modeling a round wire that will be swept along our 3D sketch. So to determine our cross-section diameter of the wire, we're going to inspect the mounting hole in our lift shroud with our 3D measurement tool again. So I'm going to come in here and I'm going to grab this cylinder and get a dimension. So we can see our hole is 4 millimeters. So we're going to make our swept protrusion slightly smaller than that. So I'm going to hide our background components. So we're going to create a plane to draw our profile on. So I'm going to do a normal to curve plane here. I'm just going to do a circular 3D sketch here. I'm going to lock to that plane and draw our circle at the end point. Now my dimension for this is I'm going to do 3.8. so it's slightly smaller than the inside of our shroud. So we're now ready to sweep along our 3D sketch. So to do that, I'm going to go back in and do a swept protrusion. I'm going to pick my path here, and then my profile, and there's our 3D sweep along our 3D sketch. I can turn off the 3D sketches and also the plane, and we can mirror this component then. So I'm going to grab my protrusion from Pathfinder and mirror it across my base plane. With synchronous technology, we can easily make a change to our model, and with the help of live rules, maintain that symmetry. So we can come in and make a change to our diameter here and make it smaller. So let's turn on our background components. The lift guide acts as a guide for the fryer basket, and so what we need to do is ensure that this fits within our design. We need this guide to be resting up against the back face here. So to do that, we're going to select our guide. I'm going to deselect two faces up here because I don't want these ends to move at all. And then I'm going to relocate my steering wheel down to an area that's easier to make a move. I'm going to offset our steering wheel then just to the front edge of this. So I know my wire is 3.8 millimeters wide, so I'm just going to divide that by 2. Now I know I'm on the edge of it. And I'm simply going to move this over so that it attaches to the key point here. And now I know that it's touching that face. We can do a front view on our view cube to prove that we have a nice fit there. We can then close and return to our subassembly level. Here we can kind of see the purpose of the wire. If we turn on the other components, you see our handle and our basket. If we do a drag component on our handle, you'll notice how the basket moves up and down nicely on those guide wires. So if we close and return and come to the very top level, we're going to show all the components here. You can see our bowl. The purpose of the guide wire is also to keep the basket in the middle of the fryer, so we need to adjust our wire a little bit so it's touching the wall of the bowl. So to do that, I'm going to select our wire and our bowl and say show only. We can use synchronous technology again to stretch the loop using a tangent relationship between our loop face and the inside face of the bowl. And so now they're touching one another. So if we can do a show all here, you can see what we've made. So that's our new 3D sketching. The last thing I want to talk about is keyshot. So I'm going to open up another assembly here. Some of you might recognize this from older versions of Solid Edge. But keyshot rendering software, it's now installed with Solid Edge and replaces our ST6 advanced rendering. So this is now part of Solid Edge and doesn't cost anything additional. If you haven't used keyshot before, it's pretty awesome. So what I'm going to do is I have some motors applied to my model here. I'm just going to quickly animate them. So to do that, I'm just going to copy this. What I want to do is I want to animate this cover opening and closing. And I also want to animate the latch moving into the open and close position. So I'm just going to do a little copy paste here real quick. And let's go ahead and play that. See, our latch moves, our cover comes up and open. I'm going to stop, it'll come back around, close, our latch will close again. So what we can do here is we have a keyshot animate button. If I go ahead and click that, it'll give me some keyshot options. I can choose what resolution I want for my rendering. For now, I'm just going to stick with the default setting here. You can also choose your output quality. Just realize the higher the resolution, the larger the file you're going to have. So when I'm done with that, I can hit OK. And it'll start to generate my animation within keyshot. Keyshot will then open and we'll get a nice preview of my assembly in there. So there's my nice calculator. Let me make this full screen. So with KeyShot, it gives us a live render, so that's why if I rotate this, it looks pixelated. The longer you let it sit, the clearer the image gets. If I want to, I can pull up the animation here and play that, so you can see it opening and then closing as well. So I'm going to turn the animation off for right now. What I want to do is apply some materials to this. I've already got some custom ones picked out and created my own material here. I'm just going to add some blue custom paint to it, some metallic paint to the main body. I can add some rubber to the grips on the sides, as well as to the sides of the buttons. I'm going to add some hard red plastic for our button. Now there's a screen underneath this that I want to be a green screen. So what I can do is I can right click and I can hide a part, so I can see through it, and I can apply my green clear plastic. To bring my part back, I'm just going to right click and say show all parts, and I can come in here and animate this. There you can see our animation with all of our nice colors. If I want to, I can render this out, which I've already done, so I'm just going to close down a KeyShot for now and open up my rendering video that I created earlier. So there's our calculator opening and closing. I'll play that one more time. That was a little quick just so you can see it. So in the What's New Part 2, I'll cover some more features of KeyShot, but I just want to let you know again that it is now included at no cost in ST7. So that's all I had for today. Here's kind of the agenda of what I'm going to cover in my Part 2 of What's New in Solid Edge ST7. We're going to be talking about the assembly environment, some new behaviors with the insert component command, relationships in Pathfinder. We also have a new command called duplicate component, which is pretty sweet to help speed up inserting components into your assembly. We'll take a look at express route and the fixed length enhancement with that. And we'll get into some framing, the preferred plane and axis. They've kind of redone the options dialog box for framing. And then also the main thing I really want to talk about is some performance enhancements with assemblies, that being limited update and limited save, and also the component tracker. So we're going to spend a lot of time on that in the next. So we're going to spend a lot of time on that in Part 2. We'll also cover drafting. We'll just kind of go over some of the enhancements in here. The table in place edit is pretty cool. Some new options with that. Some coordinate dimensioning enhancements and automatic coordinate dimensioning. So we'll cover all this again on September 4th. So be sure to register for that. That's all I have for today. I appreciate your time. If you have any questions for me or any topics or future lunch bites, please email me. Once again, I appreciate your time. Thanks and have a great day.